All right, let's take a look at the multiple choice section here. So we have a projectile launched. This is the horizontal component, vertical component, no air resistance, and we want to know when we're at the highest point. We want to know what the horizontal and vertical velocities are. So at the highest point, we only have horizontal, but we always have a downwards acceleration due to gravity. So that rules out choice A, B, and C. We do have horizontal velocity, so that gives us choice E as an answer. And then we want to know, this is the velocity as a function of time, so we want to know what the position as a function of time is. So let's kind of draw it out a step at a time. So for this first part, I move forward gaining speed, then I continue at a steady speed, and then I slow down to a stop moving forward. And the graph that most matches that is choice D. Next. And a descending elevator has a certain mass. It's decelerated over 8 meters. There's a tension of 1100 newtons. And we want to know the speed of the elevator at the beginning of the descent. So we have v squared is v naught squared plus 2 times a times this 8 meters. Now here's the thing. We don't actually have gravity as the acceleration because we're not in free fall. That's the whole point of an elevator. If you have an elevator question and your acceleration is 9.8, you are effectively killing your passengers. So we don't want 9.8. So 0 squared is the speed at the bottom. V naught squared is what we want to find, so 2 times a times 8. So now we want to get the acceleration on the elevator, so we have this cable force, which is 1100 newtons, and then we have this weight force, which is 1000 times 10, which is 10,000. That's m times g. So what's the net force? It's 11,000 minus 10,000 equals 1,000 times a. So that's giving us an acceleration of 1 meters per second squared. So we're getting that v naught squared, and that's it's a acceleration that's in the opposite direction of the elevator's motion, so it's -1. So v naught squared equals 16. V is 4. All right. Now here we did this one in class, but I just want to refresh your memory that the acceleration of the block is going to end up being F cosine theta minus F minus M, and the friction force is going to be mg F over mg minus F sine theta. We get that from our free body diagram. We have F, mg, normal force, friction. This is F cos theta. This is F sine theta. So we have that the normal force equals mg minus F sine theta. And we got F cos theta minus the friction is m times a. All right. So that's how we get those next two problems done. Here we're going around a circular path on the ends, constant speed the whole time. So what that means is if we are starting at P and going to Q, we have no acceleration, acceleration here, no acceleration, and acceleration here as we go in circles. So we kind of need a graph where it's what we've got 0 acceleration, and some acceleration, 0 acceleration, and then some acceleration. So that rules out A, D, and E. And since we're starting at P, and we're going to assume that we begin at P and we're moving counterclockwise. So we're going from P to Q, so we have no acceleration to start with, and that's how we get choice B. Next. A target lies flat on the ground, and we want to know the horizontal speed needed to hit the target. Let's get the falling time. 10 is 1/2 10t squared. So t is the square root of 2. And then we want to get the speed, so that's v equals, x is v naught x times t. So that's 3 is v naught x times square root of 2. So 3 over square root of 2 meters per second. So that wraps up the multiple choice section of the exam, and we'll post both these results online now.